Fine. So firstly, inheritance comes into picture whenever we are talking about reusability. Fine. So we want whatever classes we are writing, we want those classes to be reusable. Right. So in order to reduce the effort involved in developing the same features again and again, and also to reduce the development and testing time, the time which is required for developing and the effort which is required for developing, and also the time which is required for testing. So when we design a mechanism which is reusable, we definitely are able to uh, cover these three problems: developing the same features again and again, the time required for developing, and the time required for testing. Right? Now, C++ will allow us to reuse the classes which we have written, and this is done by creating or writing a new class that reuses the properties of our existing classes, right? Or the classes that are written before by us. Right? That is called as inheritance. The mechanism of deriving a new class from an old one is called as inheritance. Right? Why it is required? Because already the old class, whatever you had written, is having the same features. And if you require those features, may it be in terms of data members, may it be in terms of functionality, then if those set of features are required in the new class, then why to create a new class? Simply, you can inherit the same features from the old class into our new class. And this is nothing but inheritance. I hope it is clear. Okay. So formally, we can say that the capability of a class to derive the properties and characteristics from another class is called as inheritance. Okay. So the old class or the existing class which you are using, that is called as the base class or the parent class, whereas the new class that you have got is called as the derived class or the subclass. Understood? This parent class is also called as superclass. Okay, fine. So just remember these terms. Okay. Any doubt in this? Anyone? Of inheritance case, that suppose we are we want to uh, have a class animal. Now there are basic functionalities of every animal, that is eating and sleeping, right? So we form a base class called as animal and we mention a few functions in it. Now, the moment we are deriving a new class called as dog, which is nothing but an animal, along with the common functions like eating and sleeping common amongst all the animals, we have some of the specialized functions for the dog specifically, that is nothing but barking, right? So the the thing that we want to understand over here is every derived class will have its own data members apart from the inherited ones, and it will also have, it can have some specialized functions which are not part of the not part of its base class. Understood? That is the reason why we are creating a new class. Otherwise, if there was no different data member, if there was no different function, why would have we created a new class? Understood? So that is the reason for creating separate class. But at the same time, we don't want the data to be redundant. We want to avoid the efforts for creating this existing functions. We want to avoid the effort of testing them, right? And we certainly don't want to waste the time again. That is why we are inheriting it and then creating a few functions which are required in that particular class. I hope the concept is clear by now. Fine. So if we consider vehicle is our base class or parent class, then every vehicle, for example, truck or car, whatever we have, is a vehicle, and we can consider them as my derived class. Fine. There are a few components which may vary, right? So, for example, we can consider the number of tires are different uh, in case of truck and car. Fine. A few functionalities may be different in case of truck and car. That is why we have to create some specialized class for that purpose. And the thing is that every inheritance has a uh, is a relationship. Now, how do we read this? Car is a vehicle. Car is a vehicle. Similarly, truck is a vehicle. So this is called a is a relationship between your derived class and the base class. Fine. So only when there is a relationship present between two classes, we can use the concept of inheritance. Otherwise, there's no point. Fine. Yeah, same thing. The subclass, the class that will inherit the properties from another class is called as the sub or derived class. And the superclass is nothing but whose properties are inherited in the subclass, commonly called as base class or superclass. Okay. Now, apart from the specialized function that every vehicle will have, right? These three functions will be common. The capacity, the fuel amount, apply brakes. There are many others, but let us consider for every vehicle, these three functionalities are common, and that is why they will be inherited into every function. Sorry, into every derived class, apart from the other functions of the specialized classes. Fine. Okay. General examples of the is a relationship. So we can say a car is a vehicle, as we saw just now. Orange is a fruit. So fruit is my superclass. Orange is my derived class. Likewise, any other fruit can be a subclass of the base class fruit. A surgeon is a doctor. Doctor is my superclass. Surgeon is my derived class. Like physician can be other derived class of the superclass doctor, right? A dog is an animal. We saw an example. Animal, the superclass. Dog is my derived class.